Okay, ladies and gentlemen, so today what we went over in class was solving radical equations. Okay, so everything about this topic is literally in the name. Radical means square root. So radical is another word, remember? It's another word for square root. And then equations. Last year in 7th grade, they should have hammered equations in class. So we're talking about one-step equations, two-step equations, and then equations with distributive property. We're going to go over those equations second semester of this course. But for today, we're going to do simple radical equations. The reason why we're going over this topic is because next semester, when we go over Pythagorean theorem, we're going to need to know how to solve radical equations. Not only that, this topic is also preparing us for next semester when we're actually solving equations. And not only that, this topic is helping us with square roots and radicals to get more practice. Okay, so if you were absent or you need help, write these down in your notebook. These were the problems that we went over in class. So the first one we have is this one, number 1. X squared equals 121. Another word for this 2, you guys told me was exponent, but you also call it x squared equals 121. Now, this is known as an equation, a radical equation, because it has an equal sign. So that's an equation because it has an equal sign. Now, hopefully last year in 7th grade, your 7th grade teacher told you that a variable, which is the letter, wants to be by itself. We want to have the variable by itself. Variables want to be loners. They want to be by themselves. In this case, if you look at this equation, the variable is almost by itself. That little 2 at the top, or that exponent, is pretty much blocking that variable, okay? And the variable wants to be by itself. We need to get rid of the exponent. Well, to get rid of something in an equation, we'd use something called inverse operation, the opposite of something. For example, the opposite of a positive, to get rid of a positive, we use a negative, okay? In math, the opposite of an exponent is a radical. The opposite of an exponent is a radical. The opposite of an exponent of 2 is a square root. You're going to find out in a future video that we also have equations that look like this. But it has a 3 as an exponent. We call that x cubed. In that case, we're going to get rid of that exponent using a radical, but a radical known as a cube root, which you will find that out in a couple of videos. But let's focus on this one right now. In order for you to get rid of the exponent of 2, you use a square root or a radical. Boom. If you do it to one side of the equation, you do it to the other as well. Okay? Now you're going to figure out that the exponent and the square root cancel each other out. The reason why is they're inverse operation. They're opposites. It's like a positive and negative. They're 0. So you need to show me that they cancel out. It's not just drawing those square roots. So this square root destroys the exponent. And you know what happens, ladies and gentlemen? The variable is now by itself. Okay, and that's what you wanted. The goal is for the variable to be by itself. We just destroyed the exponent by using inverse operation. And this is easy. What's the square root of 121? What two numbers, if they're the same, gives you 121? Hopefully you said 11. Okay? We're not done though. Remember, whenever we do a square root, we have 2 answers. We either have a positive answer or a negative answer. And ladies and gentlemen, that is it. That's how you solve a radical equation. Very simple. Let's do another one. Number 2, x squared equals 16 over 169. Again, we have an equation. There's an equation because it has an equal sign. You also have a variable. And then hopefully you also realize that you have an exponent, okay? And then the reason why this is called a radical equation is because in order for you to get rid of the exponent, the opposite of an exponent is using a radical. So let's do that. The inverse operation of an exponent is a square root, also known as a radical. If you do it to one side, you have to do it to the other side, okay? Remember, the exponent and radical, they're enemies of each other. They're inverse operations. So what happens is that this cancels with that. They eliminate each other, and the best part is, the variable just comes out all by itself, and that's what we wanted. Don't be afraid of these square roots. We already did these problems in a previous video. So if you're stuck with this, look at the previous video. Just do it step by step. Square root of 16. What number, if you multiply by itself twice, gives you 16? 4. So you have 4. Same thing for here. What number, if you multiply it by itself twice, gives you 169? So a hint, if you forget, is I always start with 10 times 10. That gives me the square root of 100. And then keep on going until you get 169. 11 times 11 is the square root of 121. 12 times 12 is the square root of 144. So 13 times 13, yes indeed, is the square root of 169. So this is 13 right there. And this is, don't forget, positive, negative. Okay, and that is your answer. Your answer is an a proper fraction, because the numerator is less than the denominator. So this is simple radical equations. Let's do a couple of more. Number 3, x squared equals 196 over 81. And you know what? Let's take out the x. Let's put a different variable. Let's say a squared. Oh my God, it's the end of the world. Mr. Hernandez changed the x to an a. It's the same thing. It's a variable. A letter is a variable. Focus on eliminating the exponent. You eliminate an exponent of 2 by using square root. So let's do square root on both sides. Okay? You have to show me this step. The square root eliminates with the exponent, and the variable just comes out. Okay? The next step is, what's the square root of 196? Well, the square root of 196, who knows? That's a huge number. Come on, people. Just keep on going. If you know that 13 times 13 is 169, 14 times 14, if you do long multiplication like they taught you in elementary school, you'll find out that 14 times 14 is a 196. So square root of 196 is 14. Square root of 81, that's easy, 9. Positive, negative, and you're done. That's it. That's an improper fraction, because the numerator is bigger than the denominator. Okay, so that's how you solve that one. Can we get a little bit more difficult? Yeah, we could. Let's give you a decimal. Number 4. Again, I'm going to change the variable. Y squared equals 0.36. So I'm getting a little bit more complicated. There's different ways to attack this problem, but I'm going to show you the fastest way. You already know that this is a terminating decimal. At first, a lot of people will say 6, because 6 times 6 is 36. You're sort of correct, but that's not the right answer. I suggest you do something. Remember, this is a terminating decimal. Can you convert a terminating decimal into something that you know how to work with, such as a fraction? Let's try that. The 6 is on the hundreds place, so that's actually 36 over 100. Drop this down, you didn't touch it. And look at this, people. By turning that into a fraction, it makes it easier to find the square root. Once again, to eliminate the exponent of 2, we do the square root. If you do it to one side, let's do it to the other. Okay? The square root and the exponent eliminate themselves. They're opposites. It's an inverse operation. So y pops out equals square root of 36 is 6. Square root of 100 is 10. Positive, negative. And there you go. That's the answer. Of course, you could simplify this if you want. You always want to simplify, in this case by 2. So that will give you y equals 3/5. And ladies and gentlemen, if you convert that into a decimal, your answer should also be 0.6. So any of these two answers, I will accept, because they're all the same, as well as this one. But for this one though, I'll give you partial credit, because you had to reduce all the way down. And that's it, people. That's a simple decimal, how to solve it. Let's do one more, just for extra practice. So this is example number 5. So x squared equals 16, 0.16 or 1600ths. Okay, once again, I'll do this trick. Let me convert this decimal into a fraction. Okay, so x squared equals, that's on the hundredths place, so that's 16 over 100. And look at that, ladies and gentlemen. It just made it super easy now. To eliminate the exponent, I do square root. If I do it to one side, I also have to do it to the other side. There it is. This is called a radical equation. The reason why is, has an equal sign, and you're using a radical to eliminate the exponent and to isolate the variable. So x is right here, all by itself. The square root and the exponent cancel each other out. Square root of 16 is 4. Square root of 100 is 10, positive and negative. And there you go, people. That's the answer. Can you reduce it? Yeah, you can. So I can reduce it by 2. So positive, negative 2/5. And if you want to go a step further, turn that into a decimal, the answer could also be 0.4, positive and negative. So this could be an answer, that could be an answer. That's a good answer too, but I'd rather accept the reduced version or you turn it into a decimal. And that's it, ladies and gentlemen. This is how you solve a radical equation. When you have an exponent of 2, you just do the square root on both sides and apply what you learned about square roots, and then you'll be able to isolate the variable and find the value of that variable. And that's it. We'll see you on the next video.